Assalamualaikum and a very good morning. My name Mohamad Azam bin Ramli. I am engineering student from UiTM Shah Alam Selangor. Today I will present my final year project FYP proposal presentation to fulfill my syllabus course to get my degrees. My supervisor for this topic is Dr. Muhammad Faizal bin Mohamad and my co-supervisor is Dr. Muhammad Shahriman Adenan. Computational Fluid Dynamics (CFD) simulation on horizontal tube furnace. Table of contents. This presentation contains 5 important parts that are project summary, introduction, methodology, expected result, and project planning. These 5 points from table of content will elaborate the detail in the horizontal tube furnace simulation. Number 1. Project summary. This project is computational fluid dynamics (CFD) simulation of mixing 3 different gases that are methane, ammonia, and nitrogen. These gases will be mixed in 3 different inlet positions that are triangle, horizontal, and vertical. The gases mixing will produce under constant temperature of 500 degrees Celsius in low temperature nitrocarburizing hybrid process, and all of this will be done by using OpenFOAM software. Number 2. Introduction. Background. First, the horizontal tube furnace is known as heating device, but the specific meaning is device that used to perform process synthesis and purification of inorganic compound product. The horizontal tube furnace can operate higher temperature exceed 1000 degrees Celsius by using electrical energy source. This furnace is good because it is single zone chamber and the heat can be reached 360 degrees all over the furnace. The furnace been used widely in thermal process, for example, annealing, drying, coating, calcination, accelerated egging, and much more. Second, from the previous research, an example done using a horizontal tube furnace in low temperature nitrocarburizing hybrid process found that the process is useful to improve the surface properties of duplex stainless steel (DSS) without change the anti-corrosion properties. The improvement can be seen by the formation of hard diffusional layer that known as expanded austenite and expanded ferrite. Third, not to forget, another example also been done on multi-specimen found that the surface improvement is not uniform in the thickness layer on the surface improvement. Lastly, this study been done to study the effect of flow mixing in 3 different types of inlet toward flow inside the horizontal tube furnace. Literature review. CFD is defined as application of conservation law with boundary and initial condition in mathematical form. It is useful for determine variable quantity on merge of the product. For example, the CFD can determine heat, motion, force, and more. This software is launched on the early 21st century and the demand of this software increased significantly when the globalization and improvement of technology like internet. This software needs 3D numerical model data to construct the simulation. Meanwhile, the fluid flow is categorized as external or internal, and for this project, the fluid flow categorized as internal flow because the fluid flow happens in the confined space. There are 3 types of fluid flow that can happen in any condition that are laminar, turbulent, and transitional. For the transitional, the fluid flow happens between the laminar and turbulent with the Reynolds number 2300 to 4000. Lastly, the Renault average Navier-Stokes (RANS) equation is generated from Navier-Stokes NS equation because the NS equation cannot solve the turbulent condition in fluid flow. The relation with this project can be seen with the use of K epsilon because the precise performance of CFD can be get based on the renormalization group R and G. Problem statement. There are a few problems that can be seen from this project. First of all, what variable to be considered and can affect the thermal process inside horizontal tube furnace. This can be seen from the reaction of fluid flow and the surface improvement. Next, non-uniformly layer gain by the hybrid process on the specimen. This may be happen due to the lack of contact by the fluid flow to the specimen. Moreover, what behaviors of flow mixing toward fluid flow inside horizontal tube furnace? Objective. The objective of this project is to investigate the effect of different inlet configuration on the flow structure within the tube furnace. By that, three inlet conditions been chosen that are triangle, horizontal and vertical with three inlet source. Next, to evaluate the mixing process within the tube furnace at different locations toward development of uniform surface layer on the specimen. This development can be observed by uniform thickness layer of surface improvement. Scope and limitation. Firstly, the project scope is drawn 3D modeling using SolidWorks software to construct the numerical model. The scope also to simulate the CFD simulation using OpenFOAM software so the evaluation of fluid flow can be performed. Next, the turbulent flow and steady mixing inside horizontal tube furnace. Moreover, the project also focused on three-phase gases only, which are methane, ammonia, and nitrogen. Although there are a few limitations to complete this project. First limitation is lack of information about dimension of tube furnace, aluminium board, and specimen because the dimension been taken from previous study. Second, limitation for this project is longer time for simulation because many variables need to simulate in the OpenFOAM software. Number 3. Methodology. Flowchart. Here are a few processes that must be done to complete this project. Firstly, the measurement is took for the specimen, alumina board, and horizontal tube furnace using the unit millimeter. The dimension being used to construct the 3D CAD model assembly for all apparatus and three variables by using SolidWorks software. The finished 3D CAD model assembly been transferred to STL file and checked. If there any problem with the assembly, the new drawing update is compulsory to get precise assembly. If there no problem, the STL file can be used in the OpenFOAM software with the setup of boundary condition, meshing, and solution setup. After done, the CFD simulation be run for all three variables. The data been analyzed after the simulation finish. Lastly, come out the result and discussion from the analyzed data. Number 4. Expected result. Preliminary result. Here are the drawings that had been drawn by using SolidWorks software with the three variables that are triangle inlet, horizontal inlet, and vertical inlet. Meanwhile, alumina board, specimen, outlet are constant variable for this project. Next, the full assembly by all variable. Moreover, the expected result that can be elaborated is the effect of multi-phase inlet toward the fluid flow inside the tube furnace is elucidated. Next, the effect of fluid flow mixing towards surface improvement by increase of thickness is elucidated. Lastly, the effect of low temperature nitrocarburizing hybrid process toward volume of fluid flow inside horizontal tube furnace is elucidated. All of these expected results are simulated using OpenFOAM software. Number 5. Project Planning. Project Planning. Lastly, the project is conducted through this project planning and the plan is about 28 weeks in total. For this proposal, the FYP is done in 14 weeks with some activities as shown. In first 2 weeks, the title selection for FYP. Next, the title registration in week 3 and project planning and modeling for week 4 to week 6. Moreover, the journal finding and literature review are done in the same duration from weeks 5 to weeks 13. Then, the methodology been done between previous activity on weeks 9 to weeks 13. Moreover, the submission proposal and video presentation been conducted for 2 weeks on week 13 and week 14. These 2 weeks are used to improve the proposal if there have any problem. Thank you for watching my FYP1 proposal presentation. Hope the panel enjoyed this presentation and any question may ask me through my email and WhatsApp given.